Hello everyone. In today's video we are going to see how to solve the questions based on combinations. I have picked all my questions from the past papers. Let's get started. Combinations. A combination is any selection of objects where the order of the object is immaterial. That means the order doesn't matter in combinations. If I say that A, B, C and B, A, C, they are considered as the same. So the difference between the permutation and the combination. So permutation, this is an arrangement, and combination, this is the selection. In permutation, order matters a lot. In combination, order doesn't matter. Permutation can be written as NPR, which is given by factorial n divided by n minus r factorial. Combination is written as NCR, which is equals to factorial n divided by factorial r multiplied by n minus r factorial. In permutation, PQ and QP are considered as different, and in combination, PQ is considered as PQ only. Similarly, in permutation, if I say PR and RP, they are considered as different, but in combination, PR is considered as one thing. Now, the number of combinations of R objects from n different objects is given by NCR. Let's take one example. Tickets for a concert are given out randomly to a class containing 20 students. No student is given more than one ticket. Now there are 15 tickets with you. Find the number of ways in which this can be done. Now you have 15 tickets which you have given to 20 students. So we have to pick 15 students out of the 20 students. So we have total number is 20 students we have, and we have to choose 15 students to give 15 tickets. So this can be done in 20C 15 ways. If I solve it here, this can be written as 20 factorial over 15 factorial over 20 minus 15 factorial, which can be written as 20 times 19 times 18 times 17 times 15. I'll open it till 15 divided by 15 factorial, and this can be written as 5 factorial, which is equals to 15 factorial got cancelled with 15 factorial, 20 cross 19 cross 18 cross 17 over 5 cross 4 cross 3 cross 2 cross 1. If you solve it, your answer will be 15504. Now, there are 12 boys and 8 girls in the class. Find the number of different ways in which 10 boys and 5 girls get ticket. So we have out of 12 boys, 10 boys will get the tickets, and out of 8 girls, 5 girls will get the ticket. So we have 12 boys and 8 girls, and we have to choose 10 boys and 5 girls. So this can be done in 12C10 and 8C5 ways. But you are doing it together, so we have to multiply our answer. So it will be 12C10 multiplied by 8C5. So if you put it in the calculator and if you solve it directly, your answer will be equal to 3696. Now, all the boys get tickets. That means 15 tickets you have and you are giving it to all the boys. So we have 12 boys, so all the boys are getting the tickets. So 12 boys are getting 12 tickets. Now you have left with 3 tickets, which should be given to the girls. Now we have 8 girls left, in which we have to pick 3 girls to give 3 tickets. So we have to choose 3 girls. So this can be done in 12C12 multiplied by 8C3, because we are doing it together, so we have to multiply our answer. So 12C12. So this can be written as factorial 12 over factorial 12 and 12 minus 12 factorial multiplied by 8 factorial over 3 factorial and 8 minus 3 factorial. Now here, if you can see that 12 factorial will got cancelled with 12 factorial, and you are left with 1 over 0 factorial. So that is equals to 8 cross 7 cross 6 cross 5 factorial. I'll stop at 5 factorial because 8 minus 3 is 5 factorial. This can be written as 3 cross 2 cross 1 multiplied by 5 factorial. So 5 factorial will got cancelled with 5 factorial. As you know that factorial 0 is 1. So only thing I have to solve it is 8 cross 7 cross 6 divided by 3 cross 2. So 3 cross 2 is 6. So it will got cancelled from here and my answer will be 56. Here we have learnt one more thing. If we have n, c, n, so our answer will be considered as 1. Whether it can be 2c2 or 10c10, your answer will be equal to 1. So the total number of ways are given by 56. That will be your answer. Let's see one more example. A school has 3 concert tickets to given out at random to a class of 18 boys and 15 girls. Find the number of ways in which this can be done if there is no restrictions. Now you have to give 3 tickets to 18 boys and 15 girls. In total there are 33 students you have, in which you have to give 3 tickets. So you have to pick 3 students out of the 33 students. So in total I have 33 students. So I have to choose 3 students. So this can be done by 33c 3 ways. So if you solve it in the calculator, your answer will be equal to 5456. Now 2 of the tickets are given to boys and 1 ticket is given to a girl. Now as you know that we have 18 boys and 15 girls. Out of that I have to give 2 tickets to the boys. So that means I have to choose 2 boys out of 18 boys. Now I have to give 1 ticket to the girl. I have 15 girls, in which I have to choose 1 girl to give the 1 ticket. So this can be done in 18c 2 ways and 15c 1 way, because we are doing it together. So I have to multiply my answer. So my answer will be equal to 18c2 multiplied by 15c1. So if you solve it in the calculator, your answer will be 2295. Now at least 1 boy gets a ticket. So that means it is at least. So this question can be done with 2 methods. So I'll tell you both the methods. So in the first method, you have 18 boys and 15 girls. Because he used the word at least. So that means, and you have 3 tickets with you. That means maximum you can choose 3 boys. So you have to choose either 1 boy and then you have to pick 2 girls, because you have to give 3 tickets. Either you have to pick 2 boys or 1 girl. Either you have to pick 3 boys and 0 girl. So this can be done as, so out of 18 boys I am picking 1 boy. This can be done as 18c1. Now 50 out of 15 girls I am picking 2 girls. This can be done as 15c2. I am doing it together, so I have to multiply my answer. Now here I am picking 2 boys. 18c2 multiplied by I am picking 1 girl. This can be done as 15c1. Now here I am doing 3 boys. So 18c3 multiplied by I am picking 0 girl. So it will be done as 15c0. Now if you solve it, your answer will be equal to 1890. Here if you solve it, your answer will be 2295. And if you solve this, your answer will be 816. So because we have done it separately, so I need to add all my answers. So my answer will be 1890 plus 2295 plus 816. So my answer will be 5001. So this is the first method. Now we will do it the same question with the second method. So when they use the word at least, do it with no boys. That means consider that you are not giving the tickets to any one of the boys, and subtract it from the total, which we have already done in part 1 with no restrictions. So this means that all the tickets are given to the girls only. So we have 18 boys and 15 girls. Out of 18 boys, you are picking 0 boy. And out of 15 girls, you are picking 3 girls to give 3 tickets. So this can be done as 18C0 multiplied by 15C3. Let's solve 18C0. So 18C0 can be written as factorial 18 divided by factorial 0 and factorial 18 minus 0 factorial. So this will be written as 15C3 only. Now if I solve it here, it will be 18 factorial, 0 factorial is 1 and this will be 18 factorial. So 18 factorial will get cancelled with 18 factorial and 15C3 is as it is. So it will be, answer will be only 15C3. So my answer will be equal to 455. So here we have learned one more thing, 18C0. So if I do it NC0, so that will be written as factorial n over factorial 0 and factorial n minus 0 factorial, which will be equal to factorial n over factorial n because factorial 0 is 1. So this will got cancelled and your answer will be 1. So if you solve 12C0 or 5C0 or 7C0, your answer will be equal to 1. So the total number of ways are given by 33C3 minus 15C3. I have to subtract it from the total. So if you solve it in the calculator, your answer will be 5001. Now let's see one more example. A committee of 4 senior students and 2 junior students is to be selected from a group of 6 senior and 5 junior students. Calculate the number of different committees which can be selected. Now you have 6 seniors and 5 juniors. Out of them you are selecting 4 senior students and 2 junior students. So this can be done in 6C4 and 5C2 ways because I am doing it together, so I have to multiply my answer. So it will be 6C4 multiplied by 5C2. So your answer will be equal to 150. So one of the 6 senior students is a cousin of one of the 5 junior students. Now calculate the number of different committees which can be selected if at most one of these cousins is included. In this case, let's understand the question first. So he says that one senior and one junior, they are cousin to each other. So if I have to select one senior, then I can't select the one junior. If I have selected one junior cousin, then I don't have to select the one senior cousin. So one senior cousin has already selected, let's suppose that. Then one junior cousin will not be selected. So as you know that we have 6 senior students and we have 5 junior students. So one senior cousin I have already selected. So senior students will be reduced to 1. So it will be 5 senior students will be left. And now I can't select the one junior student which is the cousin of the senior one. So that means out of 5 junior one junior cousin is gone. You can't select that. So the number of junior students will be left with 4 juniors. Out of that you have to select 3 senior students because how much we have to select? We have to select 4 seniors and 2 junior students. So out of 4 seniors, I have already selected 1. So it is reduced by 1. So we have to select 3 senior students and junior students will remain the same, which I have to select 2 junior students. So this can be done in 5C3 and this can be done in 4C2 ways because I am doing it together. So I need to multiply my answer. So this can be written as 5C3 multiplied by 4C2. So if you solve it, your answer will be equal to 60. Now, one junior cousin has selected, then one senior cousin will not be selected. So if you can see that we have 6 senior students and 5 junior students. Out of 5 junior students, we have selected 1. So junior student will be reduced by 1. So I can't select the senior student also, which is the cousin. So the senior students will be also reduced by 1. So it will be 5 senior students. Now out of that, how much you have to select? As you know that we have to select 4 seniors and 2 juniors. One junior I have already selected. So that means it is left with only 1 junior and 4 senior students I still have to select it. So this can be done as 5C4 and 4C1 ways. So if I'm doing it together, so I need to multiply my answer. So it will be 5C4 multiplied by 4C1. So if you solve it, your answer will be equal to 20. Now, third part is no cousin has been selected. That means you are not selecting both the cousins. So we have 6 seniors and 5 juniors, and we are not selecting 2 cousins. So seniors will be reduced by 1. So it will be 5 seniors will be left, and juniors will be reduced by 1. So it will be 4 juniors. And you have to select 4 seniors and 2 junior students. So this can be done in 5C4 and 4C2. So I'm doing it together, so I need to multiply my answer. So it will be 5C4 multiplied by 4C2. So your answer will be equal to 30. So in this question, we have done it with 3 different parts. So I need to add my answers. So the total number of different committees are given by 60 plus 20 plus 30, which is equals to 110. Now let's see one more example. Lock can be opened using only the numbers 4, 3, 5, 1. State whether this is a permutation or a combination of digits, giving a reason for your answer. Because there is a digits 4, 3, 5, 1 and you are making a lock. So in this case, the order matters a lot. So this is a permutation. So let's write down the answer. It is a permutation because the order matters. That will be your answer. Now let's see the second part. There are 20 numbered balls in a bag. 2 of the balls are numbered 0. As you can see that number 2 is 0. 6 are numbered 1 and 5 are numbered 2 and 7 are numbered 3 balls as shown in the table below. 4 of these balls are chosen at random without replacement. Calculate the number of ways this can be done so that the 4 balls have the same number. So as you can see that I have made 4 crosses here. So either the ball has numbers 1, 1, 1, 1 or it should be 2, 2, 2, 2 or 3, 3, 3, 3 or 0, 0, 0, 0. 0 can't be happen because only number of balls numbered with 0 are 2 numbers and you are taking 4 balls, which is not possible. So I cancelled that answer. So it should be either 1, 2 or 3. Now, one number of 1 balls you have 6 and out of that you are selecting 4 balls. Number of balls with 2 number you have 5 balls and you are selecting 4 balls. Number with 3 you have 7 balls and you are selecting 4 balls. So this can be done in 6C4, 5C4 and 7C4 ways. Because I am doing it separately, so I need to add my answers. So it will be 6C4 plus 5C4 plus 7C4. So if you add it, your answer will be 55 ways. Now, the 4 balls all have different numbers. So you have number 0, 1, 2 and 3 and you have 4 balls with you. So we have to select each 1 ball we have to select. So total we have 2 balls with 0 number. We have 6 balls with number 1, 5 balls with number 2 and we have 7 balls with number 3. Out of that we are selecting 1 ball. So this can be done in 2C1, 6C1, 5C1 and 7C1. Because I am doing it together, I am selecting all the 4 balls. So my answer will be 2C1 multiplied by 6C1 multiplied by 5C1 multiplied by 7C1. If you solve it here, your answer will be 420 ways. Now, the 4 balls have numbers that total to 3. Now, you have, this is your chart we have. Now, the total number should be 3. You are picking 4 balls and your number should be 3. Either it should be 1, 1, 1 and 0. That add up to 3. Either you have 2, 1, 0, 0. still you have the number 3. Either it should be 3, 0, 0, 0. The last part we can't take it because I have picked 3 zeros, but the total number of balls with 0 are only 2 with me. So I have to cancel this answer. So only answers are left with 1, 1, 1, 0 and 2, 1, 0, 0. So out of 6 1-numbered balls, you are picking 3 balls. So this can be done in 6C 3 ways. And then you are out of 2 0-numbered balls, you are picking 1 0 ball. So this can be done in 2C 0 ways because I am doing it together. So I need to multiply my answer. So if you solve it, your answer will be equal to 40. Now here 2 balls. We have 5 2-numbered balls. You are picking 1 ball. So this can be done in 5C 1 way. You out of 6 balls, you are picking 1 ball of 1 numbered. So this can be done in 6C 1 way. And out of 2 0-numbered balls, you are picking 2 balls. So this can be done in 2C 2 ways. So if I'm doing it together, so I need to multiply my answer. So if you solve it, your answer will be equal to 30. So the total number of ways, because I have done it separately, so I need to add my answer. So my answer will be 40 plus 30, which is equal to 70. Let's see one more example. A committee of 4 is to be selected from 7 men and 5 women. Find the number of different committees that could be selected if there is no restriction. As you can see that I have 7 men and 5 women and I have to choose 4. So the total number of men and women I have is 12. Out of that I am choosing 4. So this can be done in 12C 4 ways. So if you solve it in the calculator, your answer will be 495. Now there must be 2 male and 2 female members. So we have 7 men and 5 women. Out of that we are choosing 2 men and 2 women. 2 female members we are picking. So this can be done in 7C2 and 5C 2 ways. Because I am doing it together, I need to multiply my answer. So my answer will be 7C2 multiplied by 5C2. If you solve it, your answer will be 210. Now, a brother and a sister, Ken and Katie, are among the 7 men and 5 women. Find how many different committees of 4 could be selected so that there are 2 male and 2 female members, which must include either Ken or Betty but not both. Now, we need to understand this question first. We have 1 brother and 1 sister, so we can't select both together. Either should be one can be selected. So we need to select, suppose Ken, then Betty will not be selected. So Ken is a man. So we have total selection of 2 men and 2 women we have to select. We have 7 men. So out of that 1 man I already selected. So it is left with 6 men. And we have 4 women because I can't select the Betty. So the woman will be also reduced by 1. So we are left with 4 women. Out of that, because I have already selected 1 man, so only left with 1 man I have to select, and woman I have to select 2 women. So this can be done in 6C1 and 4C2 ways because I am doing it together. So I need to multiply my answer. So my answer will be 6C1 multiplied by 4C2. So if you solve it, your answer will be equal to 36. Now we suppose that we selected Betty and the Ken will not be selected. So we have left with again with 6 men and 4 women. So we have reduced by 1 man and 1 woman, and we have to select 2 men and 2 women. Out of that 1 woman I already selected. So 1 woman will be reduced from here. So I need to select only 1 woman and I need to select 2 men. So this can be done in 6C2 ways and 4C1 ways. Because I am doing it together, need to multiply my answer. So my answer will be 6C2 multiplied by 4C1. So if you multiply this, your answer will be 60. So the total number of ways, because I have done it separately, so I need to add my answers. Total number of ways are given by 36 plus 60, which is equals to 96. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.